Hello everyone, it is an honor to present at the second International Conference on Smart Automation and Robotics for Future Industry. My name is Bernardo Farrero, and today I will be discussing the smart carving of hard-shell fruit with CO2 laser, focusing on acorn shelling. The main objective of our research is to develop an efficient and automated method for acorn shelling, integrating smart automation to improve productivity and efficiency. This article refers to one of the main objectives of the MegaCornet project, to develop a continuous industrial processing line for acorns. This presentation will focus on step 4 of the production line, the shelling of the acorn. The acorn shells and kernels have economic value. Precise shelling avoids damaging both. But what is the problem with acorn shelling? One of the main challenges in acorn processing is the lack of size homogeneity between different species and individual fruits. This lack of homogeneity makes it difficult to develop an effective and consistent universal shelling method. To approach this challenge, we explored a method that involves precise carving of the acorn shell to facilitate controlled cracking. By strategically weakening the shell, we can improve the efficiency of the shelling process. The method we propose is the longitudinal carving of the acorn. The process involves the internal tension of the acorn shells, which shrink during the drying phase due to the water loss. Due to the longitudinal carving made only on the peel, its contraction during the drying phase allows to easily expose the core of the fruit, allowing a clean separation of the peel and the core. So, how do we achieve precise carving? The answer lies in laser technology. By using a CO2 laser, we can create highly controlled incision with minimal material waste and high repeatability. A plan divided into main stages was developed for an automated system of longitudinal carving with a CO2 laser on acorn to favor their shelling. The schematic representation, in Figure 4, shows the processing expected by the acorn carving machine, where the acorn continues to move 1 towards the CO2 laser, 2 generating the sulfur carving, 3 which will then carve separating shell and core in the dehydrating process, 4. This diagram illustrates the step-by-step process of the carving method. The laser applies a precise cut along the designated line, ensuring uniformity across different acorns. In our experimental phase, we conducted a series of tests with an 80-watt CO2 laser. These tests helped us to determine the optimal parameters for the efficient carving. 6 experiments were performed. The aim was to avoid completely carving the acorn shell and to avoid burning the area surrounding the carved section. The result of this experiment is the optimal configuration that would guarantee carving without burning the shell, which confirmed the use of laser for this type of process. Based on our test, we established the ideal laser parameters that maximize efficiency while maintaining the integrity of the acorn. These include a specific output power and head speed. During the test, the parameters were adjusted until an ideal result was obtained, which was achieved with an exposure of 6 seconds and 50% of the laser power. This parameter will differ depending on the characteristics of the acorn. To further optimize the process, an intelligent system with self-optimizing capabilities is proposed. This system will analyze each acorn after carving and adjust the laser setting in real time to account for size variation. Adaptive control of laser power, head speed, and carving pattern helps minimize the thermal damage of the acorn, reduce energy consumption, and improve aperture uniformity. The line has a real-time self-adjusting system, improving the carving efficiency in each production site. In conclusion, our research demonstrates that longitudinal carving using a CO2 laser is a viable method to improve the efficiency of the acorn shelling. With smart automation and real-time adjustment, we can enhance processing precision and reduce waste. Thank you for your attention, and I will be happy to answer any question.